Welcome back to the workshop for one last video in section 3.2, probability distributions. Let's take a look at our notes. Oh, my notes are missing. Here we go. There they are. So for this video, we want to take a look at a theorem, but before we look at the theorem, I want to essentially discuss what the theorem talks about. And to do that, I want to consider this example 3.2.4. So the cumulative distribution of x is found by adding up the probabilities up to the value that we're plugging in, right? So f of 0 is the probability of them having 0 girls in the context of this particular problem. F of 1 is the probability of them having 0 or 1 girl. F of 2 is the probability of them having 0, 1, or 2 girls. And F of 3 is the probability of them having 0, 1, 2, or 3 girls, okay? Any one of those possibilities. So if I were given this cumulative distribution, I should notice that f of 3 was given by f of 2 plus the probability of having 3 girls. So if I know the probability of having 2 or less, and I know the probability of having 3 or less, I should be able to quickly identify that probability of having exactly 3 by taking the probability of 3 or less and subtracting, right, the probability of 3 or less, and subtracting the probability of having 2 or less, identifying exactly the probability of having 3. And that is all that our next theorem states. So if the range of a random variable x consists of a finite number of values, then being listed here in ascending order, right? Strictly, it'd be ascending because you wouldn't have two of these being the same, otherwise it would just be that one value. So it is ascending. So if these are the possible range values in the range of the discrete random variable, then we have two things. The probability of there being of exactly this first thing happening is exactly the cumulative probability of that first thing happening, because there's nothing before it that was added to that probability. And everything beyond that, we can find the probability of this exact outcome occurring as the probability of that outcome or less occurring minus the probability of all outcomes below it occurring. So again, in the context of the couple having 3 girls, so the couple having 3 children, I didn't include this as an example because I honestly didn't think it was worth having an example. So if you're good with this, go ahead, get out of here, have a great day. But if you want some clarification, check this out. So we found that f of 0 was equal to 1/8, and hey, look at that. Yes, the probability of having exactly 0 girls is 1/8. So that matches. Now f of 2, f of 1 minus f of 0, capital F, would be, we said that 1 was 1/2, so 1/2, minus f of 0 we just said is 1/8. This is 3/8. And hey, look, that is in fact the probability of having exactly 1 girl, because f of 1 is f of 0 plus f of 1, right? This thing is f of 0 plus f of 1. So then when we subtract f of 0, of course, we're left with f of 1. Okay, that shouldn't be a surprise. And that's exactly how this continues on. So f of 2 minus f of 1 is equal to 7/8 minus 1/2, which is also 3/8, which is the probability of having exactly 2 girls. And then f of 3 minus f of 2 was 1 minus 7/8, which is 1/8, which again is the probability, as we already saw, of having exactly 3 girls. Okay, so hopefully if what this said, the language was a little bit unclear, hopefully this clarified what was going on. So that's all that we have for this, and that is the end of section 3.2. Woohoo! So I'll see you guys back in the workshop a little bit later. Have a great day.